MATLAB Simulink of single phase full bridge inverter circuit. Now to make Simulink model, we have to open MATLAB, then we will have to move to the Simulink written here. So we will be moving to Simulink. When this Simulink file will open, then we will click blank model. We will open this blank model. Now your Simulink page has opened. Now you can see here we are having this one. This is Simulink library. So we will click on this. So in this library we will get all the components required to make the circuit. Now in your inverter circuit, if you go to the inverter circuit, you can see in inverter circuit basically you are having this one switch with diodes, one DC voltage source, and you are having load here. So to make the circuit, that means first we want DC voltage source. So search DC voltage source. Next we are having here switches. So we will be taking IGBT as switch. So we are taking this one, IGBT diode, IGBT with diode. Next we have to provide load, maybe of resistive, maybe of RL. So we will be taking series RLC branch. Next we are having power GY. This we have to give. We are now to measure voltage across the load resistance, we have to connect voltage measurement block in parallel. This is nothing but a 1 volt meter. So voltage measurement block we have to take. We have to take current measurement block also. This we have to connect in series with the load to measure load current. Next, to see the output, we have to connect scope. So we will take scope here. And to give pulses, get pulses to the switch, we have to take pulse generator. So we will take pulse generator. So now we will move to the circuit diagram. So first you have to give this DC voltage source. Then we are having switches. So switches will be 4 switches will be there. So copy it and paste it here. So first, before paste it, you will just double click on the switch of show measurement port, then click on OK. To rotate this one, press Ctrl R and then you copy it, Ctrl C, Ctrl V, Ctrl V, Ctrl C. So this is our 4 switches. So the connection will be like this. We have to connect this one. and this one. Now we have to connect load. So first we will be using R load. So control R to rotate the device. Here we will select R load. Okay, and this load is connected between these two arms. So this is connected between this and this. And this is the R load we have connected. Now we will have to get pulses to the switches. Now as we can see here, this gate pulses are 180-degree phase shifted. That means when gate pulses for switch 1 and switch 2, and switch 1 and switch 2 is on, your switch 3 and switch 4 is off. That means 180-degree phase shift is there. Now when we will give gate pulse to the system, so we need two pulse generator for this. We need two pulse generator for this. One pulse generator we will be giving to switch 1 and switch 2. Another pulse generator we will be giving to switch 3 and switch 4. So this pulse generator we will be giving to switch 1 and switch 2. Same pulse. And this pulse generator will be giving to switch 3 and switch 4. So now we have to change the settings, right? So for pulse generator for switch 1 and switch 2, we give amplitude 5. We will consider 50 Hz frequency. So if 50 Hz will be the frequency, then time period will be 1 by frequency, that means 1 by 50. That will become 0.02. Pulse width we will be giving 50%, and no phase delay we are giving here for switch 1 and switch 2. But for switch 3 and switch 4, we will have to give this 180-degree phase shift. Now this 180 degree we have to convert it into second, because here you have phase delay in second. So this 180-degree phase shift, that we have to give here in second. Now when we will convert that into second, that alpha is equal to omega into T1. So T1 is the phase delay, that time will be in second. So omega into T1, omega is, you know that omega is your 2 pi f. F is 50 Hz we will be taking, and alpha is 180 degree phase shift. The another pulse is of 180 degree phase shift. So your T1 will become alpha by omega. That means 180 divided by 2 pi into 50. It will become 0.01. So here we will be providing phase delay as 0.01. That means 180 degree phase shift. Pulse width same, we will be giving 50%. Time period 1 by 50, that is 1 by frequency, so it will be 0.02. Amplitude we will be taking as 5. So this is the settings of the pulse generator. Now to measure voltage across the load, we have to connect voltmeter in parallel, that is voltage measurement block in parallel. So we will make it parallel. Next we have to connect scope here. Now to see current, we have to connect current measurement block in series. So here we will be connecting current measurement block in series. We will be connecting current measurement block in series to measure the amount of current flowing through the load resistance. Now we are having scope here. One scope is required, not two. We will be connecting scope. Now first we will change the settings. DC voltage source we will be giving 230. 230 volts we will give. Resistance will be chosen as 100 ohms. Pulse generator settings already I have discussed, nothing to change now. Achha, now we have to see voltage, current and two pulses. That means your scope should have 4 parameters. So the layout of your scope will be like this. This 4. Number of input ports will be 4. So this is the layout. So now we can connect the scope. Or you can do one thing, you can use one mask here so that you can see the pulse. You can use mask also. Marks you can use. So what we will do is we will use marks here. So this one will connect to pulse generator 1. This one will be connecting to pulse generator 2. So your scope is having, so this one we will be connecting here. This is basically get pulses. And this one we are having voltage. This is output voltage. This is output voltage, and output current through load is here. So your scope is basically having 3 layouts. Number of inputs will be 3. So now we will press run. So this is the graph we are getting. This is the graph we are getting. You can see this is the get pulse. So this is the get pulse for pulse generator 1 and the reverse opposite one for pulse generator 2. And this one is your voltage. So we are getting minus 230 to plus 230. The voltage will be there and corresponding current will be here. We are getting voltage and current will be in phase. So these two pulses are 180 degree phase shifted. Now we are giving these pulses like this. In another way also we can give this get pulse. Another way also we can give this get pulse, that is using this same pulse we can give this get pulse. If you delete this one, we can use one not get. Not get will reverse the signal. So we will use not get. Logical operator we will take. Logical operator we will take. We will double click on this one. Number of input ports will be 1 and we will take not get. Now what we will do is we will connect not get here. Pulse generator is connected with not get and this output we will give to this get pulse. This is 180 degree phase shifted, you can see. Now if you check the get pulse, if you check the get pulse, make this one, number of input ports, make input ports 4. Okay, make input ports 4 and make this layout 4. So what we will do is, this is your pulse 1, this one is your pulse 1, that means here for this one, this is your pulse 1. This is your pulse 1. And this is your pulse 1, and this last one is your pulse 2. This one is your pulse 2. This is the output of the NOT gate, and here you are having voltage. So now press on run button. You can see the same output you will get. You can see this is your gate pulse 1 and this is your gate pulse 2. So you can see when this pulse is off, this is on, and when this is on, this pulse is off. So that means these two pulses are 180-degree phase shifted. So using NOT gate also we can create the same pulse. So in two methods we can give gate pulses to the switch. First one is that calculation, we can give the phase delay for the pulse generator, and second one we can attach one NOT gate to the original parts, and output of NOT gate we will give to S3 and S4. So both the pulses will be phase shifted. So this two way we can connect this one, we can do this one. Now we have done this for R load. Now nothing but change this R load into the RL one, make this RL, make this inductance as 150 millihenry, and run the simulation. You can get the value. So you can get, so this is your pulse 1 and pulse 2, 180-degree phase shifted pulse. This is the structure of current. Obviously current will rise exponentially, this one, and then current will decrease exponentially due to the inductive nature of the load. This is the waveform for the voltage from minus 230 to the plus 230. So this is basically the waveform for RL load. Now here you can see that this current is increasing here up to T2, and then finally current is exponentially reducing and current will come to 0. So this simulation you will have to perform, and you will have to do it in your home. You have to practice it, and you have to finally you prepare the soft copy, and then finally you will submit it. Okay, so thank you.